You talked earlier about the beauty of the nights at Rocky Hill. It must be tremendously dark here. How far out into space can you see on a good, clear night?
On a clear night from here, you can see pretty much forever. it's, you can see quasars 5 billion light years away. That's light that's older than the Earth. It's very easy to image and also to see galaxies that are hundreds of millions of light years away. So it's kind of astonishing. We're not that far from a major city, and there's some light pollution in the sky. Our skies are not wonderful the way you would find in the Chilean Andes or the Australian outback or the middle of the South Pacific. But and that's kind of one of the secrets of stargazing, even in the middle of a city. From Times Square in Manhattan to a site that's dark enough that you can have a lot of fun and see stuff with a small telescope is less than an hour's drive.
One of the parts of the film that was interesting is how amateurs and professionals, I presume, select certain elements within the universe as their focus of their study. And I wondered if you could help walk us through what some of the characteristics are of the objects that you can study at different levels. And let's start with the moon.
Every amateur astronomer has his or her own preferences of what kind of things they like to see, and the moon fascinates some people. Others find it, dead and dull. You can get beautiful views of the moon along what's called the terminator, the point where between sunlight and shade, because the shadows are so stark on the moon in the absence of an atmosphere. When you have a mountain peak that's illuminated by the rising sun, and beneath that it's just black, it looks like a rock hovering in space. So most lunar observers like to observe along the terminator. The full moon can be hypnotizing too, and I've occasionally I like to observe the Apollo landing points, like the first Apollo 11, the first place that humans set foot on the moon. If you look at it during a full moon, particularly through binocular eyepieces where you're really seeing a lot of light, there's something magical about it, sort of enchanting. It's a kind of a Jonathan Swift landscape, and to realize that there are still these lunar bases sitting there is quite fascinating.
How was the moon created?
Well, the best theory now is that the moon was created by a glancing impact from an object almost the size of Mars when the Earth was very young, when the Earth had just formed its crust. Planets like the Earth, when they form, differentiate. You've got a molten ball. So the heavier elements, typically iron, sink toward the core. So you get an iron core. And the lighter elements, the silicates, tend to float on the surface. And as the surface cools off, you will get a crust. And that's still the planet we live on today. It's still molten down there, and we're living on this crust. Once the crust had formed, but very early in the Earth's history, when there's still a lot of other protoplanets going around, it appears that a big one came by and hit the surface and blew a lot of that crustal material off, formed a ring. The Earth, for a little while, had a ring like Saturn, and that ring coalesced into the moon. The reason that astronomers believe that's the case is that the moon's a lot lighter than the Earth. It has a lot less iron, a lot more silicate. So there had to have been a mechanism to have formed it from the surface materials. And we do know that in the early days there was an awful lot of planetary impacts. And so the whole Earth being here and having its moon seems to be the chance result of the fact that we had a glancing impact rather than a direct impact would have had quite a different outcome.
If I'm out at night with my telescope and I want to look for asteroids or for a comet, what would I look for?
Well, most amateur astronomers who are looking to discover asteroids just image space along the ecliptic, which is the plane where the planets and most of the asteroids orbit. And even a short exposure, as your telescope tracks along with the stars, because the asteroids are moving around the sun, you'll get a pinpoint image of the stars, but you'll see a little streak with the asteroid. I get those streaks all the time in images that I take of other objects. And I assume that they're all cataloged asteroids, but some of them aren't. And if you're looking to discover a new one, you just take all the ones you've imaged and you check them against the catalogs. You computers will do this for you now. And then maybe one will come up and it'll say, well, gee, I don't have any asteroid that fits this parameter. So you follow that one a bit longer and you send in the data to the central clearinghouse, and they'll tell you if you've discovered an asteroid. And if you have, they'll tell you that you're free to name it for yourself or for your child or for your aunt, but they'll ask that you please do not attempt to name it for your house cat.
It's curious to me why historically we've associated comets with disasters, either pending or just occurred. Could you help us understand the reason for that?
People tend to be frightened of what they don't understand, and since people understood virtually nothing about the night sky until science came along, big changes in the sky did frighten people. Eclipses of the sun, which are frightening for good reason, because if you start on a warm, pleasant day and then the sun is completely blotted out, and it does make you feel uneasy. After all, what would happen if it didn't come back? Comets have an appearance. They can be quite big in the sky, and they can appear threatening. In a sense, they are threatening, since a big comet striking the Earth would be a terrible event. Also, to some degree, comets were exploited by those who take advantage of the fact that what someone can predict, he can pretend to control. So there's always somebody willing to step forward and say, there's this terrible disaster threatening. God is unhappy with you. But if you do what I say, it'll come out okay. And, if you realize it's going to come out okay anyway, and if it doesn't, there'll be no one around to blame you, then you can take a step up on your dubious career path that way.
Were we to determine that there's a high probability of an asteroid impact, is there anything technologically that we could do about it to avert the orbit?
If you find an asteroid that's going to hit Earth in the future, you don't want to blow it up. Blowing it up just turns a bullet into a shotgun blast. What you want to do is to alter its orbit. And the earlier you get there, the less it takes to alter its orbit. The Earth is a very tiny target in space. It's hard to hit the Earth. If you think of guiding a spaceship back to Earth, it takes a lot of work to avoid missing the Earth. So if you have an asteroid that's actually going to hit the Earth in the future, 2 years, 5, 10 years in the future, it takes a very slight change. So the easiest thing to do is to send a rocket there. It doesn't even have to have people with it. Land it on the asteroid, and then just use that rocket's engine to change the orbit a bit. Change it a little bit, give it some time, watch how the elements play out, and you just gently nudge it out of the way.
Let's move out to the planets, and one of my first questions really is the definition of a planet. I gather that's been the subject of some discussion recently.
Well, a planet is an object that shines by reflected light of its home star, in the case of our solar system, the sun, and which is large enough to meet some sort of definition. It turns out that there are a lot more objects orbiting the sun than people used to think. So back when we were all taught that there were 9 planets and the outermost was Pluto, astronomers hadn't yet discovered that there are millions of objects like Pluto beyond Pluto. They're called Kuiper belt objects after the astronomer who first charted them. And Pluto is a Kuiper belt object that happened to get pulled into an orbit that brings it inside the orbit of Neptune, so it was naturally mistaken for a planet. Observing the planets is a lot of fun, particularly with a small telescope because they're so accessible. Jupiter and Saturn are large enough that you can see them much of the year, and even a small telescope will show you their many satellites, the changing features in their atmospheres. The atmospheres of these giant planets, like Jupiter and Saturn, are opaque, so they're made of colored gas that you can actually see. So you can see weather patterns. It's sort of as if the entire planet were like the weather map that the weather person shows you on the evening news. The inner planets, Mars varies in its distance a lot from the Earth, so you want to observe it when it's close at hand, what's called opposition. During those oppositions, you can see a lot of detail on Mars. The planets, planet Venus shows phases like the Moon. It's in terms of size and mass, it's a twin to the Earth, very easy to observe in a telescope. And even the outer planets, Uranus and Neptune, with a small to medium-sized telescope, you can You can see that there's a disk, there's a distinctive color, rather greenish for Uranus, bluish for Neptune. You're looking, at a big planet, even though it's light hours away.
How long is it that we've known, actually, there are planets outside of our solar system, so-called extraterrestrial planets?
When I was a boy growing up and reading the popular astronomy books, it was hypothesized that lots of other stars ought to have planets. There wasn't anything about the sun that made it unusual. There are billions of stars like our sun in our galaxy alone. They have the same composition, they rotate at the same rate. And since the sun has planets, it seemed reasonable to assume that other stars do too. The trouble is you couldn't see them, and you still can't. The planets are much too close to their stars. They're lost in the glare. Stars are much too far away. There's still no telescope on Earth that can actually directly see a planet of another star. But techniques were developed now in recent decades that allow you to extract the information that the planets are there from the very subtle dynamics of the stars, just the way the star is slightly tugged on gravitationally by its planets. And hundreds of planets of other stars have been discovered in this way now, and it seems clear that stars typically do have planets.
In the movie, you have this wonderful depiction of an exoplanet crossing in front of a star. Is that another way for determining the existence of the extraterrestrial or exoplanet?
Yeah, the methods that are used now to detect extrasolar planets tell you if the star has planets, but they don't tell you the orientation of the system. Planets form in a disk, so they continue to orbit their star in that disk thereafter. That's what we see here in the solar system, and that disk projected on the sky is what we call the ecliptic, and that's where the sun and moon and all the planets orbit. They don't stray over the rest of the sky. So when the professional astronomers identify a star that has planets, the question immediately arises, does the plane of orbit of these planets happen to be such that those planets are going to pass between the star and the sun? You still can't see them, but what you see is a very slight change in the brightness of the star caused by this miniature eclipse. And that's where amateur astronomers have come in, and we saw one of them in the film, that if you just by monitoring these stars and keeping close track on their brightness hour by hour, you can tell if a planet transits, and what's more, you can tell the size of that planet, how long it takes to go around its star, and if you've found one, you'll find others. That's the transit method can't necessarily accurately detect all the planets. The method, the astronomers may have only found one planet orbiting the star, but if that planet transits, then other planets may transit as well. So you may discover other planets. So it's possible now for an amateur astronomer in the backyard telescope to actually discover planets. Something hasn't happened since William Herschel, the great amateur astronomer, discovered the planet Uranus hundreds of years ago.